Hello everyone, we are going to discuss about relation between A and B coefficients. Stimulator absorption. In stimulator absorption, the atom in the lower energy gets an energy from the incident photon and goes to higher energy level by absorbing a quantum of radiation of photon. Upward transition and B coefficient. It happens when a photon of light having energy E2 minus E1 is equal to h nu is incident on atom in ground state. The atom in ground state even may absorb the photon and jump to higher energy state E2. It is a starting point to laser. Spontaneous emission. In spontaneous emission, the atom in the higher energy level returns back to its ground state by releasing a photon of energy E2 minus E1 is equal to h nu without any stimulus energy. This emission takes place without any stimulus energy. Single photon is emitted. Incoherent radiation, low intense and less directional. Polychromatic radiation, more angular spread. Postulated by Bohr. Example, light from sodium or mercury vapor lamp. Stimulator emission. In stimulator emission, when a photon of energy h nu gets incident on an atom in higher energy level, it returns back to its ground state level by releasing two photons of energy h nu. This emission takes place with the help of stimulus energy. Two photons are emitted: coherent radiation, high intense and more directional; monochromatic radiation, less angular spread. Postulated by Einstein. Example, light from ruby or helium neon laser. Relation between A and B coefficient. Consider N1 and N2 B2 energy states, and E1 and E2 are the energy of these two states respectively. By Maxwell-Boltzmann law, n is equal to n0 e raised to e by kt. Then n1 is equal to n0 e raised to minus e1 by kt, n2 is equal to e0 e raised to minus e2 by kt. By dividing equation 1 and 2, we get n1 by n2 is equal to n0 e raised to minus e1 by kt whole divided by n0 e raised to minus e2 by kt, which is equal to e raised to minus e1 by kt by e raised to minus e2 by kt. This can be written as e raised to e2 minus e1 by kt, which is equal to e raised to h nu by kt, where h nu is equal to e2 minus e1, which is the energy of a photon. Process 1, stimulator absorption, where NAB is directly proportional to N1 cube. Then NAB is equal to B12 N1 cube. Process 2, spontaneous emission, NSP is directly proportional to N2. Then NSP is equal to 821 N2. Process 3, stimulator emission, NST is directly proportional to N2 cube. Then NST is equal to B21 N2 cube, where A21, B12, B21 are Einstein's coefficients. Then by equilibrium condition, upward transition is equal to downward transition. NSP plus NST is equal to NAB. By substituting the values of NSP, NST and NAB, we get A21N2 plus B21N2Q is equal to B12N1Q. B12 N1Q minus B21N2Q is equal to 821N2. Then Q is equal to 821N2 by B12N1 minus B21N2. Divide the equation by B21N2, we get Q is equal to A21N2 by B21N2 whole divided by B12N1 by B21N2 minus B21N2 by B21N2. Then taking A21 by B21 outside, we get 1 by B12 by B21 N1 by N2 minus 1. Then Q is equal to A21 by B21 into 1 by B12 by B21 into e raised to h nu by kt by substituting the values of N1 by N2. So by Planck's radiation law, Q is equal to 8 by h nu cube by c cube into 1 by e raised to h nu by kt. Then comparing the both equations, we get B12 by B21 is equal to 1, which gives B12 is equal to B21, and A21 by B21 is equal to pi 8 pi h nu cube by c cube. So by conclusion, we get the stimulated absorption is equal to stimulated emission, and the ratio of spontaneous and stimulated emission is directly proportional to the frequency of a photon. That's all about the relation between A and B coefficient. Thank you.